Right, hi everyone. I'm Brady Volpe. We're going to talk about updates on the network, the demand that's been driven by COVID, specifically how broadband networks need to adapt to changes for societal needs from COVID-19. This is episode 63 of Get Your Tech On. I'm Brady Volpe, founder of NimbleThis and the Volpe Firm. With us today is John Downey, CMTS technical leader at Cisco Systems. John, welcome back.
I'll always be here virtually.
Of course you are. This is our next power hour of all things Docsis. Please do drop in your comments in the chat. I'd love to hear from you and your experiences on how COVID's impacted your network, and we can talk about those. But first, we'd like if you like what you're watching, please do hit the subscribe button. And if you want to be notified of future events, please do click on the notification bell so you'll receive email notifications the next time we go live or upload videos. And also, please do be sure to stay to the end of the live stream. We do have some important announcements for free learning events. It's great info that you're not going to want to miss. So to set the stage for the conversation that John and I are going to have, we put together some slides that have some numbers. If you're listening to podcasts, we'll do our best to make sure that we kind of talk about what's on the slides. I'm going to share some information here on the screen in just a second. John, I'll talk about some of this stuff. So, John, we talked about this before, but on how COVID has impacted networks and how it's driven up a lot of traffic. One of the things we're going to talk about here is some of the numbers behind that and what we've seen. There's been a number of things that have really been driving that. I think you talked about this last time or time before on some of the things that you've seen. I don't know if you want to comment before we get into the slides.
Yeah. I was just counting on my fingers and months that this started. We're almost 6 months in,
Yes.
Half a year. It's hard to believe, since March, right? End of February. So it's interesting that we're this far in and we're still dealing with this, the aftermath, and it hasn't changed. In North Carolina, where I live,
we don't know when it's going to stop.
I know. They just announced they're not going to start up school for another 9 weeks in North Carolina. North Carolina is one of the only states still that will not open gyms and I think bars, but they opened other places, no problem, which is kind of interesting. But because, I like to work out whenever I can. So I find my own way to work out. So if schools are not going to open up, it's a slew of problems, right? People that are wanted to go start working back at the office can't.
Right.
They might have been allowed to, but they can't now because their kids are not allowed to go to school. So, a lot of people use school as a glorified daycare, if you will, right? I mean, it's get the kids out of the house, and now I can actually do what I need to do. Now somebody's got to stay home. So there's implications there. So
and Georgia's a mixed bag. I'm in Georgia. We're in Georgia, so it's a mixed bag here as well. Some schools are opening, some schools are not opening. And I think we both grew up in the north in Pennsylvania, where schools would open kind of in the late August, early September timeframe. In Georgia, schools are starting now. So some of the schools that can open have, but the majority of the schools in Georgia are doing online only. And kind of like what you're saying. And I'm curious, maybe people can throw in the chat room kind of what's going on in their world. If schools are opening up or if they're doing online only, it'd be interesting to see.
Yeah, because if the schools are not opening up to be on site and you have to do more online classes, even though we saw the spike in usage from COVID and it slowed down, and you're going to show this for the summer, it's probably going to kick back up again.
Yep.
Because the kids are going to be doing Zoom and all that stuff for school. And then the people that were hoping to go to work or maybe work 3 times a week or whatever, they're stuck at home as well. So now they're fighting over their own internet connection at their house, driving up traffic. And like we talked about, these applications, they were not as prevalent as they are right now.
And they're much more symmetrical, right?
Yeah. Yes.
That's
and the fact that even if you look at yourself traveling around, you're using your mobile phone when you're traveling, you're using your maybe a home line, if at all.
Using different networks.
I got rid of my home line. I mean, I got rid of my landline. But if I had my mobile phone, fine. But now when people are working from home and they have to do some type of audio, they're either doing it through the computer or they're doing it through Wi-Fi, maybe calling. So they
It's
might
all
be
over
using their mobile
Docsis.
phone in
Yeah.
Wi-Fi calling mode. And all that going through your Wi-Fi is best ever voice. It doesn't have a quality of service that we have with unsolicited grant service, UGS, on a Docsis modem. So that has implications, a lot more than what many people would think of, all the way up to laser clipping on the upstream.
Yes.
And there's a lot of things that come into play here when we start adding more utilization and adding applications that cause a lot of burstiness, or maybe not even burstiness, but small frames, very small frames very often.
And I think it's that and I do want to get to the numbers in just a minute that's driving this, but I think it's that symmetrical use of the network, and we're going to see that in just a minute, and how that's really changed the dynamic of it. And we'll get into the laser clipping in just a minute, and the difference between UGS and PGS and some of those things, which I think are very relevant. But let's dive into the numbers, because I think these are really interesting things of what's going on. So the first slide here comes from the NCTA, and these are kind of the key takeaways that they've talked about here, where since COVID, downstream peak traffic usage is growing 20.1% overall since March 1st. So, I mean, this is over and above what we're typically seeing, right? And that's just on a downstream. On the upstream, the upstream's even more, 35.1% growth since March 1st. So this is kind of going back to what you're talking about, where like if you're using Zoom or any of the type services, that video and voice traffic is symmetrical. We're using it on a downstream and the upstream, and I think that's why we're seeing these big growth numbers in the upstream. And then the bottom bullet point, Wi-Fi traffic. Now, those Wi-Fi or those voice calls that we were doing on the cellular network are now being migrated to the Docsis network, because we're using backhaul on the Docsis network, which, I mean, great thing. We're using more data. We're getting more traffic on our Docsis network, and also a bad thing at the same time, right?
Yeah, correct. I read another article I thought was interesting, was the usage of downstream and how much it's gone up. And I just had a thought on that. I mean, obviously the upstream, there's more upstream traffic from your downstream TCP over the top adaptive bitrate video. Netflix, Hulu TV is creating upstream acknowledgments. So there's a downstream and an upstream. But I read where some service providers relaxed their caps. So they might have been doing byte counting and capping it off, and they relaxed it during this pandemic. So that made people like, oh, I might as well download all these movies and I watch whatever I want. So the traffic spiked up on the downstream and on the upstream. So what happens if the caps are reinstated and people already consumed as much
They're in the
as
habit.
they wanted to? They're tired of Netflix, but they never are.
I don't think that's going to happen either. And we're going to see that in the numbers too.
A new marathon of some other thing comes out, like Yellowstone is a pretty cool show I'll watch.
It's a great show.
They'll get the rights to that, and then people will be binge watching, right?
Yes.
There'll be a marathon on Yellowstone. So yeah, it's always going to keep going up, up, up. So it'll be interesting to see if service providers reintroduce caps on bytes, how many bytes to download, and if that will, bring it back down or control people's appetite, or maybe that helps upsell, right? Customers, I really like the way that was, no byte cap. I'll give you an extra $5 a month for, another terabyte in a week or something. I don't know.
Yeah, there's opportunities there for revenue.
Yeah.
So, okay, the next couple of slides shows this slide is showing the downstream trend of peak consumer usage. And what we're seeing here is, starting around March 1st, there was a large spike in downstream traffic usage starting at, we're starting at the baseline of 0% on March 1st. And there was an immediate increase of 20% downstream traffic from March 1st to March 28th. That kind of continued up and around till the end of April. And then things through the summer, started to drop down into the 10% range or so. Still growth, but things start to slow down a little bit over summer, right? Where people started to relax a little bit. Things we're doing a little bit more outside, and then into August 8th, we start to see things peak up again. Now, as
Homeschooling
I
got
said,
stopped.
yeah, we're starting to, get back to work. Some schools are starting to open up again, and at the same time, things got a lot worse in a lot of states. So, starting to get a little bit back inside. Now, the upstream, I think that's the bigger story here. So, in March 1st, we started 0%, and into April, we see upwards of a 35% increase in upstream traffic growth. That remains pretty constant all throughout the summertime, staying in between the mid 20s to upper 30s, and then it starts to peak up again in August. And I think that's the story there, which we'll talk about later on with UGS and collisions and laser clipping and stuff. Again, we're seeing a huge change in upstream utilization, which is more the symmetrical usage of Docsis, which goes back to Zoom, gaming, a lot more activity that we've seen than we've had before.
Yeah, I mean it's kind of scary because the downstream we've built in enough over subscription, over provision, over capacity.
Yes,
So we had enough room to grow in the downstream because we started implementing DOCSIS 3.1 and we have more single carrier QAMs. We have primary downstreams. We get rid of some of the analog video and all of that stuff we've done to create more DOCSIS traffic capacity. But upstream, we say 5 to 42, but a lot of amplifiers are 5 to 40. You don't want to do stuff below 15 usually, so you have very limited spectrum to really turn on upstream channels. And most people are stuck at 4 ATDMA channels giving 108 megabit per second aggregate pipe.
right.
So that 108 is nice, but a 35% increase in traffic could have took you from 50% typical for the day to 85. So now all of a sudden you're in compression, or you're actually in congestion, and then you got to figure out what am I going to do about it.
Yep. So our next slide comes from an article written by Damian Poltz at Shaw Communications. This is a nice slide that shows their network traffic increase from 2013 to 2020, and we can really see the spike there that occurred from COVID. Really significant spike on downstream usage, and the article from Shaw was really interesting because it talked about that really COVID did not break the network for cable operators, and I think that's kind of a success story overall for the cable industry. How cable operators were prepared for this, and I think, John, it goes back to your prior point, where particularly in the downstream, operators had a lot of additional capacity. Many operators were already prepared with OFDM. We've been rolling out DOCSIS 3.1, so we had that additional capacity to do that. And so even though we had this really large spike that was shown on that slide from COVID, in the downstream at least, we had that capacity in many, many networks in order to absorb the spike. And that is, I think, a success story. And I've heard a lot of stories about that, and we've seen that before, where people really are seeing and appreciating the fact that DOCSIS is around, that this network infrastructure is there, that people can now start working from home, people can learn from home, and we're not seeing huge bottlenecks like maybe we would have seen 5 years ago or 8 years ago, before we have DOCSIS 3.1 and the massive amounts of capacity that we have right now.
So you and I talked about this, and I think the word I'm going to be looking for is auspicious.
Auspicious. That's the word for the day.
It is, isn't it? My bombastic word. We by chance and by luck, we're in this position.
Yes.
And we can't take total credit for it. It's because the competition pushed the cable industry to upgrade.
Yep.
And if that didn't happen,
whether that was Google or Verizon or AT&T,
Yeah.
everyone's been pushing and pushing and pushing.
Yes.
And thank goodness for that, really. Frankly, thank goodness for that.
Agreed.
So this next slide, I think, is really, and John, we talked about this before, is how, the bottom line on this slide shows what we have really become accustomed to as far as peak utilization, where, throughout the day, most people are at work, most people are at school, traditionally pre-COVID. And then at night, the network utilization ramps up between 7 p.m. and like midnight. And those were our peak utilization hours. Now, post-COVID, our peak utilization hours, as we see on this chart, are 10 a.m. to basically midnight. Those are our peak utilization hours, and it's as the line sees, and for those of you listening on audio only, apologize you can't see it, but it's kind of like a flat line from 10 a.m. to midnight as our peak operating hours. And these new peak operating hours far exceed what we used to have as peak operating hours from 7 p.m. to midnight. So huge change there and huge impact on our overall network and how we're going to manage that moving forward.
And it also is good to see this graphically because I used to argue that when's the best time to do a maintenance window? Like when do you affect people the least? And I used to think, with people going to work, maybe the best time to do a maintenance window was actually middle of the day. But it turned out it really wasn't because people working from home, still utilizing the network. And I was just looking from the Docsis side, right? Not just video. I was looking at the Docsis, but now the video is over the top, so it is Docsis.
Yep.
So yeah, there's a lot more capacity being used throughout the day. And it turns out the best time for maintenance window is probably still 2
Middle of the
a.m.
night.
to 6
Middle of the
a.m.
night. And I have to say, there's many times I've done work with operators where we could do some maintenance in the middle of the day because the chance of it really having much impact on anyone is minor. You're going to mess up someone watching Netflix or someone being sick at home or something like that. But that has so changed. Now hands have to be off the network in the middle of the day because everyone's at home working, students that are home learning. So I think that's a big lesson. Next slide. This goes back to your point, John, where you said that operators were relaxing peak usage, and that's really critical. So what we've seen is a 47% increase in capacity consumption, up from 273 gigabytes to 402 gigabytes from the same time last year. So huge percent increase. And so really appreciate the fact that operators are releasing those caps. There's no time there's no time in the past that we've needed that like we do right now because we have become, as the article is saying, more reliant on the internet since the beginning of COVID-19 pandemic that at any time in the history of the internet. It's our lifeline right now to keep working, to keep our economy running, to keep our children learning, and we're seeing that evident right now. And some of the things that are driving. Oh, sorry, John, go ahead.
Go back for a second.
Yes.
It doesn't really say gigabyte per what. I assume it's per subscriber, right?
Yeah, I mean, looking at these numbers,
gigabytes to 402 per subscriber.
Yep, I'm assuming that it doesn't define that. We do have a link down here. This is from PC Magazine /news/data usage. So people can go and look these up themselves and dive into that. But yeah, I mean, these numbers are pretty significant. So, so what's driving this, right? We have some slides here on actually what's driving this. 50,000 years of streaming media. So the amount of content America has streamed in just one day, and that day was April 4th that they measured that. Disney project, so Disney their streaming platform, they projected how much they were going to do. They blew those projections away. They did 4 years worth of their projection during the COVID pandemic. Netflix, 22% increase during COVID. Peloton. So John, I think you mentioned Peloton and you heard about this. I don't know if you want to touch on the Peloton since you're into the exercise routine.
Yeah, I mean, I know a lot of personal trainers that their studios are shut down. They can't give training. If they do, they figured out how to do it outside if the weather's nice. It's been like 95 degrees here for like a whole month. So it's tough to do that outside even. So a lot of personal trainers are doing online training, FaceTime or whatever they're doing. And even if they're doing FaceTime on their mobile phone, it's probably with a Wi-Fi calling on, right? So it's still over the cable modem potentially. And then the Peloton was interesting because, that is an interactive application. The question is it a fad? They had a blitzkrieg of advertising during Christmas and people getting it. And it also turned out that this timing was pretty good to stay focused and get motivation to exercise. For me, I can't just jump on a bike and be satisfied. I mean, but it's driving up traffic. I mean, they have those interactive mirror thingies for exercise. Yeah, who's to say something else doesn't come out like holograms? That would be the next best thing, right? You go from say 4K TV to 8K to a hologram. Now you need even more capacity to generate that hologram and then be interactive as well. I don't know what I would be sending on the Upstream. I try to send a hologram of myself or whatever.
No, we don't need that, John. But
yeah, but yeah, it's interesting the applications, right?
Yep.
These things that we never thought of.
So and it just continues. So Facebook 27% increase, LinkedIn 26%, WhatsApp two times an increase in calls and videos, TikTok 25% increase. We get into
you brought up. I got to add this. You brought up before another app on the Upstream was the Ring doorbells, and because they track maybe movement, people walking outside would make the doorbell go on, and it's going to the cloud.
And you have
should
you have a lot more
doorbell
people.
Application say, hey, if you're home, here's a feature to save the content not to the cloud, but maybe to your home, or because you're not away to watch it anyway, you're home.
But the user has to have the storage capacity at their home.
Yeah, storage is cheap. People are just going to upload to the cloud and not have to worry about it.
Yep.
But that's generating traffic on the Upstream.
Yeah, but I mean, really, a subscriber, a home user isn't going to care about whether they're using the cloud, and they're not going to want to go out and buy storage capacity. That's extra work for them. Yep. The cloud is free, unless it starts to cost them stuff.
It's convenience, and the other thing I want to point out on all the stuff you're showing is it comes right back down to content is king.
Yes.
Netflix, absolutely. Disney, whoever is providing the content. That's why 20 years ago, I said, man, as a cable industry, we can't be a dumb pipe.
Yes.
Because content is going to now just take away your pay-per-view income, which they've already done. And we need to figure out how to offer quality of service, quality of experience.
So what's interesting is we have like conflicting or combating news articles out where Charter says, oh, we're getting more video subscribers, and then on the other hand we have other operators that are saying we're getting less video subscribers, or streaming is actually increasing. So I think it depends on which operator or who's looking at the statistics. Definitely there's no question streaming video is going up. I think it's just who's presenting the numbers or how we look at the numbers that I think everyone is just watching more video right now during COVID times because we're kind of stuck.
That's a good point too.
If you're locked in, you're going to be watching video, man.
Yeah, is it semantics, or are they using the term video too broadly?
Yes.
Because it could mean over-the-top video, or it could mean the cord cutters. People actually cutting your broadcast video.
Correct. One way or another, it's coming down the pipe. So then we get into video conferencing, and most people are familiar with Zoom. So Zoom's had an amazing year with 2,900% growth. Google Meet is very similar to Zoom. It's used a lot. I use it a lot. 3,800 years. The amount of time spent in Google Meet sessions in a single day. 2.7 billion Microsoft Teams. That's the number of minutes in a single day. And Slack, also another similar conferencing system. 80% increase in new customers on Slack. All of these are symmetrical services. Slack, a lot less video in Slack, but nevertheless, they're all going to be using the Upstream. And then gaming. So there's a lot of talk. I did an article, I think just about a year ago, where I said, gaming's $1 billion industry. Now the numbers, this gaming is like a multi-billion-dollar industry now. And so way surpassed the article I did just a year ago. But what we're seeing now during COVID, again, Nintendo, 41% surge in annual profit. Activision, 2 times increase in game revenue. Particularly one huge game for them is Call of Duty Modern Warfare. Lots of cable operators talk about this because the download, just to download the first instance of the game is like an 80 some gigabyte download. And then every time these guys pump out a new update for that, it's normally like 10, 12 gigabyte. I had mentioned the same thing before with Fortnite, John. Huge downloads every time you download this game. And then we get into Bunch Live, million increase, House Party, 7% increase, every single one of these. So people are doing a lot of gaming. And then there's an article about this. They're predicting like an avalanche of additional gamers and gaming downloads coming on with some of the new services that are coming out. So this is only going to add more traffic coming down the pike.
This is interesting too, to be able to track that, and when a new version comes out, there's going to be a surge.
Yes,
right away.
It's a big download. It's almost
like, how do you
get ready for it?
The gaming companies, no, you're not allowed to release it until a week after this guy releases, or a day after. But then there's
no incentive. But that's not incentive for the gaming companies, because every time they do a new download, they make more revenue.
You need to make your network better, right? They don't care.
It all comes down to like why we built the networks the way we have to get ready for this type of activity.
To cache servers.
Yes. Yeah, and that's one way that operators can really prepare for that, because the cache server catches the first download, and after that redistributes the downloads to all of the subscribers within that network.
I mean, the capacity is still on your plant, but at least you've taken it off of your WAN backbone.
Yep. Yeah. Exactly. So I think a final couple of slides here. The cloud. And you mentioned this earlier, John. So the cloud's getting a lot. So Amazon's seeing a 70% increase. Microsoft, 775% increase. So pre-COVID, I don't think I had ever joined a Microsoft Teams meeting before. Everything was done on conference calls, telephones. You remember telephones? I don't think I make any telephone calls anymore. Everything is done on Microsoft Teams with most of the people I talk to, or Zoom and WebEx. So again, Teams, symmetrical services, voice, and most of the time we're using video or we're sharing desktops. So huge increase there. And then finally, last thing to talk about here is how phone services changed. So we did talk about phones being used on backhauled over Docsis, but it's not consistent from country to country. And this is what Statista is talking about here in this article, published by Amy Watson back in June of 2020 of this year. Different countries, so like in Germany, Austria, and the United Kingdom, less than 40% of survey participants said that they were using their phone more. But for China and the Philippines, the percentage stood at 86%. So really, it does depend. We can't just paint everyone with the same brush and say that everyone's using their phone more or less. It is broken down by country. In the U.S., definitely we're using our phones a lot less from the standpoint of we're doing things like on Teams, on Zoom, and things like that. We're doing a lot more with our computers and iPads and stuff like that.
I mean, you think about it, there could be a lot of people that rely on their phone for their internet connection, and when they weren't stuck at home, maybe they were in not libraries, but some public location or some other place with Wi-Fi hotspots or internet cafes or whatever, and maybe they didn't have internet at home, Yep. And now they're stuck at home. They're using the phone more because that's all they have, and it could depend on 4G and where we're going with 5G as well. It'll be interesting with 5G and Wi-Fi 6 and the faster capacity those things bring.
So I touching on that point, 4G, 5G, a couple of articles have come out recently how people, myself included, have added hotspots to their networks because it is so critical. If your Docsis network goes down for any period of time, having that backup of 4G or 5G for redundancy is becoming really, really important. And people are starting to do that type of stuff. People, including myself, because if my network goes down, I don't want to be without internet right now. And having redundancies built in are things that people are starting to do, and it's a really nice thing to have in place. So you don't want to
Agreed.
be without networks for
I mean, I've
without
done it too.
network
My power's
connectivity for
gone
very
out.
long.
I have like an ice storm, power goes out. The laptop has a battery, so it's still working, but then my
Right.
internet has to be out. Luckily, I did get fiber to the home, and they have a battery to the ONT. Um,
But
but it just
fibers can
goes to
get
the
cut.
that just goes to the ONT. So the Wi-Fi would still be out. The modem would still be out. So I really need a UPS for the modem side. Um, yeah, I've thought about that too. And what I usually end up doing, exactly what you did, I use my mobile phone as a Wi-Fi hotspot.
Correct. Yeah. So
And then
a lot of people are leaning back into that. So we kind of talked about the numbers here and how there's no question network has changed significantly. We have a lot more capacity. I think another thing that's happened is a lot of people that used to go to work and work in a building in a residential area, maybe a downtown, a city, something like that. That network capacity has also shifted from the city to now maybe suburbs or rural areas. So we've also had a shift in traffic of where the traffic is originating. So that has changed the network dynamically too. And that takes us, I think, now into the meat of the conversation, John, where you talked at the beginning, where this huge amount of shift in traffic is creating significantly more upstream traffic. We've seen the numbers, 35% standard, consistent upstream traffic growth. So that's causing congestion. And that congestion, John, impacts things like piggybacking, causes congestion, causes bursts, getting on top of each other, laser clipping. How do we handle that? What's the solution for that?
This is a very deep, really, conversation of how do we envision the landscape of people wanting to live in a city to be close to work to avoid traffic. And then all of a sudden you're given the opportunity to work from home. You're like, why would I pay the taxes and live in a city and deal with this when I could buy an acre of land with a nice house and work from home? So now all of a sudden, fiber to the MDU that was easy to do for a service provider into a city, now you have all that capacity needs moving out to the suburbs, and now that has to be increased. And you can't do fiber to node plus 0. You're still doing node plus 3, 4, or 5 because that's the most efficient, cost-effective way to do it. So you're still trying to, reap your return on investment of your HFC plant, and that's sort of where we are. And the question is it business as usual? Is it going to turn back? No, probably not. A lot of people and companies will probably let their people work from home. I think even your wife said that she was talking to someone from a GoDaddy or something like that, and the CSRs, customer service reps, might be working from home. So
yes.
Now that shift of not just physical vehicle traffic, now it's internet traffic shifting out to the suburbs. So we got to make sure the suburbs have connectivity. There was FCC and government subsidies for what were they calling it? Rural broadband.
Yep.
And
underserved areas.
Yeah. So I have a feeling there's going to be even more underserved areas. They were served, but they're underserved because the influx of traffic is going to be coming. So,
and we see that everywhere. I have customers in like Montana, and they say there's just a massive amount of people that are moving into the state of Montana, which that is a very, very, as we all know, it's a very rural area, very underserved area. But now the operators in those areas are just seeing, we got a lot of new customers coming in. So there's a lot of opportunity there for those operators
to cable out there in North and South Dakota.
Yeah.
And they were very aggressive with pushing 3.1, and they're looking at cloud and stuff like that. So it's nice working sometimes with smaller MSOs because they're more nimble. They have less red tape, and they're willing to try new things and almost be cutting edge. And Midco did pretty good with that, and they still are doing it. So maybe they'll start feeding Montana and the whole Midwest. And to me, fiber as deep as you can go is the way to go.
Right.
So fiber as deep as I can go, and then you just look at the cost and you do amplifiers where you need to. And then we do maybe an 85 split to a 204 split, and then we decide where to go from the 204 split in the upstream. If we can do that.
Yeah, so I think, the bottom line is when you come to network capacity and you start you start filling up the contention windows in a return with piggyback requests. You start causing your lasers to clip. There's really no solution for that other than adding more capacity, adding more upstreams, maybe going to OFDMA in the return, pushing fiber deeper, doing node splits. That's the way you mitigate that.
Yeah, let me go down that path now. And so we'll give an explanation how Docsis really works, right? Docsis is not like the old land city contention sensing collision detection Ethernet. Basically, Docsis, you make an upstream request, very small, 6-byte frame with some preamble and guard time, so it's really small. Might be 1 mini slot of time, 6.25 microseconds or 12.5 microseconds. It's really small time. Goes up to the CMTS. CMTS looks at the scheduler and says, oh, you asked for a 1500 byte Ethernet frame. On a downstream map, it's going to say, oh, here's your time to send. So the cable modem and CMTS have to do request, grant, request, grant, request, grant. That delay, that request grant cycle affects my packets per second, which affects my speed, my upstream speed. And longer distance, more time, more map advance, bigger frames, more time. If we have an application that has to do request grant, request grant, request grant all the time,
you mean like Zoom or Google Meet or any of the applications that we're seeing, like 2,000, 3,000% growth?
So the key when you do, say I'm uploading a PowerPoint slide on Upstream, and I'm going to send it to you. Mm-hmm. I'm loading my cable modem with all those Ethernet frames. It's buffering in the cable modem, and the cable modem does concatenation. And it might send a request with a concatenated frame of 3 15, 18 byte Ethernet frames all at one time.
Which means now it's not doing request, grant, request, grant. It's just sending one big packet up.
And to make this better, once the CMTS gives me time in the wire to send those 3 frames, I can piggyback a request inside.
So now it doesn't have to send a request in order to get the grant. It's just getting it's getting a grant every time it sends a packet.
That request on its own is a contention request. It could collide with me and you and 10 other people. And if you have a collision, then you have to have some type of back off. Then you got to send the request again. So if the application has enough speed to buffer the cable modem and efficiently do request, concatenate a lot of frames, and piggyback, as long as that first request goes through, I should be good because there's no more contention. Once I'm allocated time on the wire, it's my time, right? So I don't have to worry about contention. But what if the application doesn't do that? What if the application is best effort audio, and I'm not doing any video? So it's actually, I feel like I'm not causing much traffic, but the traffic I'm causing is worse.
And so the best effort audio is basically, that would be like offloading your cell phone call onto Docsis.
Wi-Fi calling. I'm doing it right now. I have such bad cell service in my house because I'm in the middle of nowhere. I have Wi-Fi calling on. So if I use my cell phone, it's going to end up doing best effort through I have fiber to the home, so I don't care.
and if I recall, when you're doing Wi-Fi calling, I think you send requests like once every 20 milliseconds or something, right? It's pretty frequent that you're sending those requests.
It's typically packetization for packet cable was either 10 millisecond or 20 millisecond. And most people set it on a 20 millisecond because you couldn't hear the jitter or latency with 20 millisecond in between the packets. So you could have a packet every 20 milliseconds. And that seems fast, but in the whole scheme of 100 megabit per second upstream pipe, that's really far in between every 20 milliseconds.
Yes.
Meaning,
so it's I just think it's every Wi-Fi call on an upstream, just a Wi-Fi call, is sending every 20 milliseconds a request to the CMTS saying, I have another piece of voice data that I want to send to you.
It's
a huge amount.
Second that are all contention requests that have the capability to collide with someone doing a Vonage call or another Wi-Fi call.
What is the collision? What happens when the packets collide?
If they collide, the cable modem will back off, and it's usually some type of exponential back off and a range, and it will try again.
But the packets the packets that collide, they're basically lost, right? The CMTS never sees those collided packets.
So here's my concern is if you're doing applications that are real time, UDP, they're not TCP, they're real time. If I back off, send the request to send my voice again, is it too late? At what point is the next voice packet need to go? Like if I'm talking, it's real time. If I have to collide back off, by the time all that happens, I'm already past that point in time. Yeah, exactly.
That's what you sound like when that starts to happen, and then people say, well, my voice, people can't hear what I'm saying when I'm talking to them on the conference call.
So it's not just the application not being efficient with contention and piggybacking. It's also how much contention time do I have in the wire? And that's relegated to how much utilization is on the wire. So the more traffic we have, the less contention time we have. The applications are creating more contention requests. So that little window of contention time shrinks. But then I have more contention in that small window. You're going to have more contention and collisions. So then you have back-offs, and it's almost like a snowball effect.
Right.
So we ran this number with one of our customers and found that, and I didn't think it'd be possible, but we saw it. You and I know what laser clipping looks like.
Mm-hmm. All
if
too well, unfortunately.
Cuts off at 42, and you have artifacts above 42 megahertz on a head-end spectrum analyzer, it's probably laser clipping.
Yep.
If you turn off the upstream and that artifacts go away, then it's probably laser clipping.
It's definitely laser clipping.
If you live in the woods, you're probably a redneck. I just feel like I'm going down the comedy act.
Yep. Well, that's why we're here to entertain, man. So the actual contention, when you have multiple packets colliding at the same time, we start to those packets build up on energy, right?
So yes. So I started saying I was mentally thinking about this, and I'm like, is that really possible? And we saw the results of it, meaning the utilization was high, contention window was low. The more traffic we saw, the more the spectrum analyzer was showing artifacts of laser clipping. And then I said, let's run some numbers here. Even if you had 50 customers doing a WebEx, creating contention requests, and the probability is only 10 of those happen to collide at the same time. Well, technically, 10 times the log of 10 is 10 dB.
Which is a pretty large number.
Power addition also is determined by frequency alignment, phase alignment, and amplitude. Everything has to line up perfectly, right? In time and phase.
If you're out of phase, the numbers actually,
it could be better.
Yeah, it would actually cancel out.
Yes.
But if they're in phase, then you have perfect addition.
So at the node, at the upstream laser, everything's the same frequency because you're transmitting on the same upstream channel.
So we match one of the criteria.
Everything's at the same amplitude because modems transmit whatever they need to do to hit the laser at the same level.
That's the second criteria.
The same.
Now it's the phase.
Negotiate time with time offsets so the cable modem and CMTS are synchronized. So I suspect everything, the stars align, and you
unfortunately
have 10 modems, only 10, and that's 10 dB spike in power.
Which is enough.
More than enough.
Depending on how your lasers are, you can start clipping a laser with that much additional power.
Yeah, we're already fully loading up our upstream with 4 upstream channels, and that's also loading up my laser, right? Before, our 4 upstream channels were bursty. But now, because they're so active, they're on like all the time.
Because we have 35% more additional upstream capacity or upstream utilization than what we used to have.
So we could easily, throw CB noise in there, throw AM radio noise in there, throw in
the normal junk
collisions in there. Yeah, now we got laser clipping.
Yep. And it happened.
So what do you do?
It happened all since COVID.
So you know what I did for these guys? I said just to test it out. I'm like, you're going to take a hit on MER, but if you go to the CMTS and just say, let's set my upstream level to -6. If I set my CMTS to -6, all the modems levels will drop by 6. So at least that gives me some headroom into the laser clipping of the laser of the node itself. And they did it, and they did take a hit on their MER, but they had enough good MER that they were okay with it. Because laser clipping it's unforgiving, right?
Yes.
I mean, it's uncorrectable FEC.
It's 100% uncorrectable when you get
Exactly.
it's 100% uncorrectable. But John, that's actually a good recommendation. One that I hadn't thought of before is just it's a stopgap solution, but you lower the receive power that the CMTS is asking the modems to come in. It's also having every modem reduce its transmit power, so you reduce the probability that you're going to have the laser clip it. That's actually a really good recommendation for customers.
Yeah, I mean, it was the simplest, at least temporary test until they could add more capacity.
Right.
Once
So
you
they can
add more
split a node, or
capacity, there was less congestion, which opened up the contention window, so there's less actual collisions.
right.
And then no laser clipping.
Yeah, I mean, another thing, if they haven't added an additional upstream, they could always do that, which is going to add more contention windows.
Yeah.
But that's probably something they've already thought of doing. But lowering the power is a very good idea. Very good suggestion.
In reality, the best way to do it would be, if you're trying to save your optical link, the best way is go to digital fiber.
Right.
Hey, there's my plug right there. If you do remote PHY, remote MAC-PHY, digital fiber, no laser clipping. That's perfect. Upstream and downstream, right? No laser clipping. But let's say you can't do that. You're still on an analog link. The best way to save your analog link is not just change the CMTS level, change the padding into the laser itself, or move padding from the head end to the upstream laser.
So what does that buy you when you move padding? Go ahead.
You're not changing the cable modem levels, because all you're doing is moving the padding. But by moving padding from the head end to the upstream laser, you're hitting the laser with less level.
Right.
Your optical modulation index is lower. Your drive to the laser is lower. Cable modems are still transmitting the same level they were before. Understand?
Are there trade-offs from doing that?
Yeah, you got to get in a truck and you got to drive out there.
It's just it's the manpower, right?
Yeah, it is. It really is.
All right. So what about PGS? Can we take advantage of that to take those continuous request grant, and put those and actually get those into a service flow? So rather than having the continuous request coming from the modem, from like say a voice call or something like that, we can actually get that into a service flow. So the continuous requests are not coming from, like, say, a Wi-Fi call that we know that Wi-Fi call is going to continuous come. Is there the capability to do that?
And before I even knew what PGS was, PGS, Proactive Grant Service, is a new service flow specified in Cable Labs' low latency Docsis initiative. So PGS is just like we have a best effort flow, an NRTPS flow, RTPS, UGS, UGS-AD. We have different service flows you can put in a CM file. A lot of times the voice call used in UGS is a dynamic quality service. So you don't put it in the CM file, you make it as part of your packet cable multimedia, and voice call is set up automatically, right?
Yes, but that does require that you have a embedded multimedia terminal adapter in order to sense that the phone has been picked up and someone's going to make the call, and then the MTA and CMTS communicate back and forth and say, wait, we've got a call going on. Let's set up that dynamic quality of service that basically and remember, says, now we don't need to send the requests and the back and forth.
Unsolicited grant service. So you're not doing request, grant. I set up the call, it's grant. It's unsolicited.
Every 20 milliseconds, the grant automatically comes down. So is there any way that we're looking as an industry, is it possible that we can do that for non-MTA type calls, and maybe a Zoom meeting or something like that?
So, and we're looking at that for gaming and potentially identifying, like we just talked about, these applications. Mm-hmm. And I had a thought on this, because you just talked about making a call and you got to dial the digits. That's call signaling. That call signaling is before the call sets up. How do you guarantee that goes through?
That's best effort right now.
That might not even go through. It's like you don't even have dial tone, or you're dialing digits and the digits aren't going through. So to give yourself insurance that the call signaling will go through during high congestion periods, we have something called NRTPS. Or you could set up call signaling with a best effort flow, with higher priority than all the other best effort flows.
Mhm.
Normally your best effort flows are all priority 0 because everyone's equal. So you say, all right, you know what? I'm going to make sure the call signaling at about 87 kilobit per second, or actually call signaling is like 16 kilobits per second or less, 8 kilobits per. I'm going to set that with a priority of 3. Or instead of a best effort with a priority, I can do NRTPS. So NRTPS is non-real-time polling service. It allows the CMTS to schedule time on the wire for non-contention requests just for that call signaling. You're nailing it up, but it's very infrequent, maybe every 100 milliseconds, and it's very small.
Yeah, when
So
you say you're nailing it up, we're reserving
nailing it up.
capacity in the return for these services.
And it could be for every EMTA on that, say, upstream. So if you have 100 EMTAs, no one's making any calls, but those 100 EMTAs are nailing up non-contention requests for each one of them.
Which means there's a certain amount of upstream capacity that's reserved that can't be used by anyone.
Correct.
So that's kind of the trade-off on that we have to
Correct.
recognize.
Correct. So I said, you know, could I use that feature for these new applications? If we could identify them or identify customers that need a better guarantee, maybe I could give them NRTPS for their actual flow. And it turns out scheduled flows like UGS, NRTPS, are relegated to a single upstream. That way we can control jitter and latency. They're not allowed to bond across the other upstreams. And it turns out NRTPS, it sets up non-contention requests, but the actual data, the best effort traffic that goes along with it, it's relegated to that same single channel. I'm like, that's a non-starter.
Yeah,
I want to
that's
offer,
a problem. Because if that channel goes down, if that channel goes, and what if that channel goes down, like a partial mode situation? Does that can we move that to a different upstream then?
But you could have multiple service flows for a cable modem, right? You could have a primary service flow that's bonded, and the modem will stay online as long as one of the upstreams is up. And then you could have another service flow just for this application that's relegated to one upstream.
Okay.
So if it goes down, the modem is still up because on a different service flow and it's still using all 4. My problem is if that application needs 50 megabits per second on the upstream, I can't do that on a single upstream.
That'll kill it. Well, first of all, the upstream won't support it.
Yeah,
and then once it tries to, it's going to crush anyone else that's on that upstream.
So all these thoughts, I'm like, is there any way that we could allow bonding? And even our own guys at Cisco, you know what? PGS is coming out. So why reinvent the wheel when we already have a new feature coming out that was meant to satisfy this stuff? I'm like, all right, cool. So PGS is what's going to help us with this. It will allow us to set up an NRTPS type of nailed up non-contention requests. And it's proactive grant service. So I could say I need 100 mini slots and here's the type of speed I'm looking for. And the CMTS gets the request and says, oh, I see you want 100 mini slots, but because you want higher speeds, I'm actually going to give you 200 mini slots. I see on the downstream map that no one else is asking for time in this map, so I'll just give you the rest to you. So it can proactively give me more than I asked for. And then it can ramp up and then ramp down depending on how much traffic there really is. The only pitfall I see to some of this is we used to do node splits based on upstream utilization. And this is the problem I have with power boost as well, upstream and downstream power boost. If you're using the pipe, it's kind of like use it or lose it. If I use the pipe and utilization looks like 100% all the time, it's giving me a false sense of congestion.
And you're saying it's going to be like that because we are pinning up some of the traffic?
No, in this case, the PGS is not pinning up really anything. It's just giving out more than I really needed or I really wanted.
And so you think that when we do this, people are going to think that they have to do node splits before they actually have to.
Correct. And I've always said that we need to track quality of experience to determine when to do node splits.
And when to add capacity.
Yeah. It's kind of like use it or lose it. You can make the argument that I'd rather give everyone equal opportunity to use the entire pipe. It's use it or lose it anyway, so it's not costing me any more for my Docsis pipe. But then how do you determine when there's congestion? That's the key. I don't care what the utilization is. I care when people are backing off and having collisions and congestion.
And when it starts to impact the
They're
end
full.
user. So,
Yeah.
so what do you think the time frame is for PGS? I mean, it sounds like a great solution for the problems that we're having.
I
You know,
6
crystal
months.
ball. I mean,
Yeah, I think
are we
6
looking at a
months.
year? Are less than a year,
No,
more than a
I think,
year?
and really, it's an implementation in the CMTS software. Um, I
So get
don't know
coding,
that
man.
there's no hardware.
Yeah,
Um,
well, I mean, that's a good thing then. It's not that we have to change out hardware. It's probably
correct.
something that we'll see it for coming out from a lot of the vendors, um, from firmware or software upgrades in some time in the future.
Well, I'll give you a little teaser on that one. Is Cisco has a proprietary feature that precluded, no, preceded,
Came before PGS. How about that?
And here I was throwing out bombastic words. I can't even think of preceded and proceeded.
Now you can't even
So
put a sentence together.
It's preceding PGS. It's DPS, Docsis Predictive Scheduler. So we already have a feature to do some of this, and it's officially going to be supported in September, so next month.
Oh, that's awesome.
And it's been a great feature for us for long distance remote PHY.
Yep.
If I do remote PHY with a long SYN, converged interconnect network, a digital fiber, I do have a lot of delay.
It's going to help with latency on that request grant cycle that you've been talking about.
And it's not just upstream traffic per se, it's upstream acts affecting my downstream TCP. So if I'm trying to do over the top video and I have a lot of speed, Docsis 3.1 modem even.
Oh, you'll get buffering because of if you don't handle the acknowledgement delay over a long link. No, that makes a lot of sense. So, all right, John, that's we've covered a lot of ground. I think there's a lot of good information that we've seen. COVID has had a unique impact on our networks. I think that things like PGS, the other technologies you're working on, I think these are going to be really interesting things coming out. Giving operators recommendations like just lowering your transmit or your receive power at the CMTS in order to combat things like laser clipping are good recommendations, and even having operators understand why they may be having laser clipping now when they didn't just 6 months ago, pre-COVID. I think these are all important things. So
you even look at power loading. If you start going Docsis 3.1 OFDMA, where you want to take advantage of the capability of Docsis 3.1 OFDMA with higher modulation schemes, you might say, let's rob Peter to pay Paul. To keep the laser from getting overloaded with power, maybe I take my ATDMAs and drop them 3 dB, or I turn on my OFDMA 3 dB. Right. That way I have better MER just on the OFDMA, and I'm using it at the higher frequency, not at the lower end. And I know my ATDMA can only do 64 QAM anyway, and the break point for that is like 23 dB. So if I got a 30 dB MER and I can afford 3 or 4 dB drop, I should be okay with that. I mean, it's a decision that has to be made, obviously.
Yep. All right, John, we have wrapped up another hour. I do want to go over some events that are coming up. Light Reading Next Gen Technologies and Strategies Conference on August 26th and 27th. This event is completely free to attend. I will be speaking, so shameless plug here, I will be speaking on the 10G panel on Wednesday, August 26th at 1 p.m. Eastern Daylight Time. Again, completely free to attend. I will have a link for the event in the show notes in the YouTube video. Also, SETE Expo 2020 virtual conference. That is October 12th to 15th. Expo this year, including all of the workshops, completely free. I want to thank a number of cable operators who have pitched in to compensate all the workshops, so everyone can attend those. So I think this year's Expo will be the absolute highest attended expos because everyone can and should highly recommend they should attend the Expo. I will be moderating the panel on Wednesday, October 14th, 9:30 a.m. Eastern Daylight Time with Ron Rannick from Cisco. I think most people know Ron. John Krastalski from Comcast and Kyle Homan on Shaw. And this panel is on what does a wider upstream path mean for signal leakage monitoring and reporting. I've already read all the papers and presentations because the peer review on this. I recommend everyone attend this panel. What does a wider upstream path mean for signal leakage and monitoring? There is so much.
You mean like a 204?
I'm not gonna give away any of this stuff in here, John. You got to attend the panel to see it. I just want to say, I'm so excited about it because I read the papers and there's so much good content in these papers and the presentations. You got to attend the panel, and it's free, man. It's absolutely free. So, John, I think are you doing something for Expo?
I got two. I got something for two.
Plug yourself, man.
I have to present twice in the same day.
Awesome.
I think one's at like 9:30 on the 14th, and the other one's like 1 o'clock or something on the 14th.
But you're doing it from right there, right? Right at your desk.
Yeah, I will be.
It's awesome.
Basically, that's it. Maybe I'll bring my chickens in with me. I did one on capacity, the stuff we've been talking about, capacity concerns, congestion mitigation, trying to figure out where the congestion is coming from. What can I do? The other one is on the power of DAA, going to digital fiber, regardless if it's remote PHY, remote MAC-PHY, I don't care. Just converting analog fiber to digital fiber, what does it do for us? And it does a lot. I mean, I don't even care if you go to FDX or some other thing that doesn't even exist yet. Just go to that digital link, like we talked about. No more laser clipping.
Yes.
I mean, right there, longer distance. There's all kinds of stuff.
So between the light reading, that's again on August 26th and 27th, and the Cable Tech Expo on October 12th to 15th, those are 4 days completely free, full of great content. I highly recommend everyone attend those and get as much out of them as you can, because you can sit at home and you can watch them and you get lots of great content. From our side, our next show that we have is August 28th. That's going to be another special edition of our cloud native virtualization with Asaf Matatayu. And then the one after that is September 11th. That'll be episode 64, back again with me and John. So we got more content coming on our side again. And then we'll have on September 25th, another full band capture, Rocking P&M with special guest Larry Wilcott from Comcast. So looking forward to doing that. So with that, John, thank you again for your time today. A lot of great content here. Our next episode 64, August 28th. Please join us, everyone. You can watch us live right here, catch up on previous episodes on YouTube, or listen to us on our favorite podcasters. So long, everyone. Thanks for tuning in. We'll catch you next time. Bye, all.
Take care.